Okay, so this one, I've got a couple points up again. I'm going to give some harder numbers. So I've been dealing a lot with just whole numbers, integers, but now I'm going to throw some fractions in. Okay, and they're not real simple fractions either, because I've got denominators that are 7, 9, and 5, and 3, and so a lot of these don't turn into nice decimals if we try it. So I'm going to try to keep everything in its exact form, and final answers will just be fractions. That's okay. Do be prepared. In my math lab, you'll see some fractions. On tests, you'll see fractions, just numbers that don't work out nice. Not all numbers that you'll see in this class or in life work out nicely all the time. And so just I want you to be prepared for that mentally and through experience and practice. Okay? So here I've got 2 points, 3/7, comma, -2/9, and 2/5, comma, 1/3. Okay? Those 2 points I'm going to, again, use to find a slope. So I want to find the slope between the 2 points, and then use that slope in one of the points to plug into the point slope form, and that'll eventually simplify to a slope intercept form. Okay, so again, our slope, we start by finding the slope, because I can't use the point slope formula without a point and a slope. And right now I have 2 points, so it doesn't quite get me there. I need the slope. So the slope is, of course, y2 minus y1. So y2 is 1/3, y1 is -2/9. Okay, and let's throw parentheses around that, -2/9. The denominator is going to be x2 minus x1, and so that is 2/5 minus 3/7. Okay, so as it looks, yeah, that looks kind of messy, right? So I need common denominators on top and common denominators on the bottom to get those to simplify. To do that, I'm going to take that off to the side for a moment. Use a different color. And so I'm going to do the arithmetic over here and then bring the answers back in and kind of get rid of the work. So if I look at 1/3, well, the double negative here is really a plus. So we're essentially looking at 1/3 plus 2/9. Now to get a common denominator, I know the LCD is 9. And so I need to multiply the 1/3 on top and bottom by 3 to get the 9 on the bottom. Right, so I'm going to multiply by 3 here and by 3 here. So both the top and bottom get it by 3. That will change that into a 3, I'm sorry, into 3/9 and 2/9. And when I add 3/9 and 2/9, I get 5/9. Remember, when you add fractions, the denominator stays, the numerators get added together. Okay, and so that 5/9 is going to be my new numerator to the slope. The denominator I'm going to find by subtracting 2/5 and -3/7. Well, I'm running out of space a little bit because I need to save this empty space on the bottom. So I'm going to erase that work. And then I'll work out the 2/5 minus 3/7. Now the LCD between the 5 and the 7 is 35, right? It's the product of those two in this case, because they don't share any common factors. To make 5 into the 35, I have to multiply it by 7. So I'm going to multiply by 7 to the top and the bottom of that fraction. And that will give me, what, 14 over 35. Right, 14 over 35 is the same as 2 over 5. To make this 7 into the 35, I need to multiply it by 5. Right, so I'm going to multiply by 5 on both the top and the bottom. 3 times 5 is 15, and 7 times 5 is 35, so that's 15 over 35. And if I subtract 14 35ths minus 15 35ths, the answer will be negative 1 35th, right? So 14 minus 15 is negative 1. You combine the numerators, and then the 35 just comes along for the ride. So my new denominator is going to be that value of negative 1 over 35. Okay, so now I have still yet another step in dividing these fractions. Now remember, with division, whenever you divide a fraction, it's the same as multiplying by the reciprocal of the denominator, okay? Some people call it I call it a copy dot flip, where you copy the first fraction. I'll write it down. So copy the first fraction, and instead of dividing by the bottom, you multiply by its reciprocal. Okay, so dot, copy dot is multiply, and then flip is taking the reciprocal, so it becomes negative 35 over 1 instead of 1 over 35. Okay, so that's the copy dot flip, or the there's lots of expressions multiplied by the reciprocal. Once I've done that, I can then actually do the multiplication. Nothing simplifies at this point. I can't reduce anything, unfortunately, and so I simply need to multiply 5 times negative 35. That'll be a negative 175, and 9 times 1 is 9. So my slope is negative 175 over 9. It's not reducible. You could turn it into a mixed number. I would stay away from decimals here, and really I would stay away from the mixed numbers because they're harder to work with as we do arithmetic later in the problem. Okay, now since I have this final answer for my slope, I'm not done, obviously. I still have to use the point slope form and get my slope intercept eventually, but I'm going to erase some of this work that I've already gone through because I don't need it up there. Okay, so I know what my slope is, and I have 2 points. Remember, in the point slope formula, y minus y1 equals m times x minus x1. In that formula, I need a slope and I need a point. Okay, the point could be either of these 2 original points. I'm going to choose the second one personally because there are no negatives, and I kind of like the denominators of 5 and 3 as opposed to 7 and 9. I think they'll be easier to work with, so I'm going to go with that one. That's the only reason, but they're really interchangeable if I don't mind using the negatives and the 7 and 9, whatever. So I'm going to say then that the slope, this is m, negative 175 over 9. I'll plug that in first. The right-hand side, since I'm already working on that, is x minus x1, which is 2/5. So x minus 2/5. Okay. The left-hand side, I haven't done my y's yet, is going to read y minus, now y1 is 1/3, so it's y minus 1/3. Okay, so I need to use the distributive property and then get my like terms together and get my y equals mx plus b, so get y by itself. So I'm going to distribute the negative 175 over 9. And of course, negative 175 over 9 times x is negative 175 ninths x, right? They just multiplying together. And then when I distribute to the 2/5, The double negative there will make a plus. So I'm going to take the rest of that off to the side here, change my color so you can see it. It's going to be 175, and again, I'm going to ignore the negatives because I already have the sign figured out. It's going to be 175 over 9 times 2 fifths. Well, what's nice about that is 175 and 5 will reduce because they're both divisible by 5. So if I divide the 5 by 5, I get 1. Divide the 175 by 5, I'll get 35. Okay? Alright. And so 35 times 2, that's the remaining factors, that's going to be 70 on top. 9 times 1 is going to be just a 9 on the bottom. Okay? So 70 over 9 is going to be the fraction hanging out over here on the end. Okay, 70 over 9. Let me get rid of this stuff in red, all my work. Okay. And now I got to get rid of my negative 1/3. So to get rid of that, I'm going to add it to both sides. Now, when you add 1/3 to the left and 1/3 to the right, notice on the right, I've got different denominators. I've got a 1/9 and a 1/3. Okay. What I really want to do is get those to be the same denominator. So what is 1/3 if I convert it into 9ths? Well, it's 3/9, right? I got to multiply top and bottom by 3. So this 1/3 in reality is 3/9, adding the same thing. And so 3/9 and 70/9 makes 73/9. So what I'll be left with is y equals negative 175 over 9 times x, and then plus 73 over 9. Okay? That's it. That's actually in slope-intercept form. So what that tells me is my y-intercept is 73/9. That'd be equivalent to, in mixed number form, would be 8 1/9. And the slope is negative 175 over 9. That means once you get your y-intercept at 8 1/9, you would go down 175 units and over 9. Down 175 and over 9. Okay. And so that would give you the rest of your line. It would be a downward slope. Okay. Again, the fractions, don't let the fractions scare you. They do definitely take extra time. There are some ways to work through those. If you needed your calculator has some fraction features on it that you could also use to work through some of that arithmetic.